Welcome. Today we'll discuss the cooling tower. We have already understood that a condenser requires large amount of cooling water for converting the exhaust steam from the turbine to condensate or water. Basically, a cooling tower ensures the reuse of cooling water for condenser. Reusing the water from the condenser, it has to be cooled again, and that is why a cooling tower is required. A tower to cool the hot water from condenser. That is a simple definition of cooling tower. Let us understand the cooling requirement of a cooling tower in a boiler power plant. A boiler produces high pressure, high temperature steam which is supplied to the turbine, and after expansion in the turbine and doing the work of giving the work output, the steam pressure is low pressure and low temperature, and this low pressure low temperature steam is converted into water again, or it is also called a condensate in a condenser. This condensate can be again used as boiler feed water, and it has to be fed to the boiler with the help of a pump called the boiler feed pump. Water required in the condenser is generally taken from a river or lake. Suppose we are taking it from the river and it is pumped with the help of a pump, and it is again coming out as a hot water from the condenser, and this hot water can be directly discharged to the river, but this water can again be reused as condenser cooling water if it is cooled in a cooling tower, and that is why a cooling tower is required. So this is a cooling tower. Water coming out of the cooling tower is generally cooled enough, and it can be reused as cooling water, and it has to be pumped with the help of a pump for circulating purpose. In the cooling pond, some amount of water is lost during the evaporation and also in the from the cooling tower. So this loss of cooling water can be compensated with this pump, and it can be taken from the river. If we have a cooling tower, then the same water can be used again and again as cooling water, and if the river cannot supply the cooling water throughout the year, or if the river cannot supply sufficient amount of water, then this cooling tower helps us reuse of the cooling water. Cooling tower is basically a heat exchanger, and cooling water, that means the hot water from the condenser, rejects waste heat to the atmosphere by making direct contact between air and water to lower down the temperature of water. So if the hot water from the condenser comes in contact with the atmospheric air, then some amount of water is evaporated and rest become cool, and that can be reused as cooling water. So depending on the principle used, it may be cross flow, counter flow, natural draft, and mechanical draft. In cross flow cooling tower, the water comes from the top and air flows like this. So they cross each other, and that is why it is called cross flow type cooling tower. And the water, cooled water, can be reserved in a reservoir or tank, and it can be reused as cooling water again. In counter flow, the direction is opposite. Water comes down from the top and air flows from the bottom to the top. Their direction are counter. That is why it is called counter flow cooling tower. Water tank, and it can be again used as cooling water. Natural draft cooling tower releases waste heat from the system and release it into the atmosphere. Hot water is pumped and water is sprayed at the top with the help of some nozzles. Series of nozzles connected to the hot water inlet used to spray water and distributed throughout the tower, and air enters from the bottom of the tower flowing in upward direction without any mechanical force, and that is why it is called natural draft cooling tower. The airflow is natural. Some water particles absorbs the latent heat and get evaporated, and the rest water become cooled. The cold water can be again directly used as cooling water, or it can be reserved in a cooling pond. From this cooling pond, it will again go to the condenser. Now, mechanical draft cooling tower. Mechanical draft cooling tower utilizes mechanical devices such as induced fan at the top or blower fan at the bottom to move air from bottom to top. Due to more air movement, the evaporation becomes fast and the cooling is more efficient in mechanical draft cooling tower. These blue lines are direction of flow of water from the top to the bottom, and these orange lines are direction of airflow from bottom to the top. This is the exhaust fan or induced fan, and it will induce the air from the bottom. The water collected at the bottom of the cooling tower is again sent to one cooling pond, from where it is pumped to the condenser again. These are the blower or forced fan. So these blowers will force the air from the bottom, and induced fan will induce or suck the air from the bottom to the top. So due to these two types of fan, forced fan at the bottom and induced fan at the top, the air movement is more faster and evaporation is also faster and cooling become faster. So this way, this mechanical draft cooling tower ensures fast cooling of water, and it can be reused as condenser cooling water. Due to the loss of water from cooling pond and from the cooling tower, the lost water can be compensated from the river or lake, the original source of the water. So this is all about cooling towers in a boiler power plant.